this is for Algebra 1, and today we're going to start graphing linear equations. And the first thing that you need to do when you're going to graph a linear equation is get y by itself. Then you're going to put the equation in your calculator at y equal, so everything after the equal sign goes in your calculator. You're going to look at your table using second graph to get there on your calculator and find 2 points to plot on your graph. Now you want good points, and when I say good points, I mean you don't want decimals if you can keep from it. You don't want big numbers. You want to stay as close to the origin as you can. You're going to plot those 2 points and then draw a line connecting the dots. I will give you rulers to help you do this. Be sure that the line you draw covers the entire graph and that it has arrows on both ends. So looking at number 1, the first step we said was to make sure that y is by itself, and it already is. So we don't have to do anything to fix that. So we're going to go to our calculator, and we're going to go to y equal, and we're going to clear everything out. And at y equal, you're going to put everything after the equal sign. So for this one, it is 5x minus 10. So then you're going to go second graph to pull up your table. And my graph looks really weird. I don't like the numbers on my table, so I'm going to go second, table setup, tell it to start at 0, tell it to go by 1, and go automatic. So now I notice that, see 0, negative 10, I really don't want to go 10 away from the origin. So keep looking for better points. 2, 0 is a good point. 3, 5 is a good point. So 2, 0, and 3, 5 are good points. I would like for you to write out to the side what your points are that you're going to use, and then go graph them. So 2, 0 means you go over 2 and up 0, and 3, 5 means you go over 3 and up 5. So then you just want to get your ruler and draw a straight line that goes through both of these points and has arrows on both ends. Now my lines aren't going to be great because I can't use a ruler using this slate here, but I expect yours to be better. Okay, see, mine didn't even get close to touching the 2 points, so that was kind of bad, wasn't it? Let me see if I can move my line a little bit. Yours should be much better because yeah, they're all connected. That's not going to work. We'll just go with that. Your line needs to go through the points. Use a ruler. And you're done. That's all there is to it. So looking at number 2, you should see that y is not by itself. So you've got to move things around. Now remember that anytime you cross the equal sign, you have to change and do the opposite. So 6x has to cross the equal sign. Look in front of it and notice it was positive. So when it crosses, it's going to subtract. Don't lose this negative, this with the y. Negative y is equal to 9 minus 6x. Now you cannot have a negative y, so you go through and you change signs of everything in the problem. So y is equal to negative 9 plus 6x. So we'll go to y equal, and we'll put in negative 9 plus 6x. We'll go to our table, and I'm going to say 1, negative 3, and 2, 3 are good points. 1, negative 3, and 2, 3 are both good points. So over 1, down 3, and over 2, up 3. Use your ruler. And these are really, really steep lines, and so they're kind of hard for me to draw. That's why you're going to use a ruler. Draw your line, put your arrows on it, you're done. All right, number 3, you should notice you have parentheses. You need to distribute and get rid of these parentheses. So this becomes y minus 1 is equal to 3x plus 6. Y is not by itself. I've got to move this one over and add it. Make sure you combine it with the other constant. You don't try to put it with the x term. So y is equal to 3x plus 7. Go to your calculator. Go to y equal, and you're going to say 3x plus 7. And then you're going to go to your table, and I'm going to say negative 1, 4, and 0, 7. Negative 1, 4, and 0, 7. You do not have to use the same points. Any 2 points should give you the same line. I'm just trying to find the ones that are closest to the origin. So negative 1, and then up 4, and then 0, and up 7. And then draw a line, go through both dots, cover the entire graph, put arrows on the end. Number 4, notice we have fractions. We're not going to panic. It's not a real big deal, but we probably want to get rid of them. So look at your denominators. I have a 4 and a 2 in the bottom. What is the common denominator, the smallest thing that they will both go into? Well, they will both go into 4. So I'm going to multiply 4 times everything in the entire problem. So you can use your calculator. 4 times 3/4. You would just do 4 times 3 divided by 4. And you're going to get 3x. Plus, use your calculator, 4 times 1/2. And you're going to get 2y. Equals, now don't forget to do this, 4 times 4, which is 16. So I got to move that 3x to the other side. And it leaves me with 2y. It's equal to 16 minus 3x. Everything needs to be divided by 2 because I've got to have y all by itself. So y is equal to 8 minus 3 halves x. If you want to turn that into a decimal, you can. Here is the thing. As long as it's what we call a terminating decimal, like this one, 1.5, and it stops, that's fine to turn it into a decimal. But if it is a long decimal or a repeating decimal and you round it, you're going to mess up your graph. It's not going to be accurate. So don't do that. Just leave it as a fraction. Go to y equal. Clear everything out, and we're going to say 8 minus 3 divided by 2x. Go second graph and pull up your table. And I'm going to say that 0, 8, no, I'm going to say 2, 5, and 4, 2. 2, 5, and 4, 2 are good points. So over 2, up 5, and then over 4, and up 2. Draw a line, goes through both dots, covers the entire graph, and has arrows on both ends. Alright, so looking at number 5, you need to get y by itself, so your first step is to move that 3x, and so it becomes 4y is equal to 12 minus 3x. Everything gets divided by 4, so y is equal to 3 minus 3/4 x. Go to your calculator. Y equal, clear it out. 3 minus 3 divided by 4x. Second table, 0, 3, and 4, 0 would be good points. 0, 3, and 4, 0. So 0, 3, and then over 4, 0. Get your ruler, draw a line, try to hit both points, put arrows on both ends. Now notice on number 6 that we have a y but no x. On number 7 we have an x but no y. Anytime you only have one letter in your equation, you either have a vertical or a horizontal line. Okay, it's not going to be at an angle. Your line has to cross whatever axis you have a letter for at whatever number they've given you. So this one is a line that has to cross the y-axis. Well, here's my y-axis. It has to cross it at 5. So go up here to where y is 5. I have to have either a vertical or a horizontal line that crosses the y at this point. This is going to be a horizontal line. It's going to go across the graph. So looking at number 7, x is equal to -2. It's got to cross the x-axis at -2. To cross the axis, it makes it have to be a vertical line. X equal and y equal will never be a slanted line. It's always horizontal or vertical. Number 8, your first thought is that y is by itself, but if you look closely, you see it has a negative y, so you have to change every single sign. Y is equal to -3x minus 2. So go to y equal. And we're clearing that out, -3x minus 2. And if you'll notice on this problem, the x term's at the beginning. On some of the others, when I move stuff, it's at the end. It doesn't matter where it's at. Okay, it's not going to change the graph. So I would say -1, 1, and 0, -2. -1, 1, and 0, -2. Let's double check that. -1, 1, 0, -2. Those are good points. So -1, 1, and 0, -2. Draw a line through both of your dots, put arrows on both ends. Okay, so this may not be on your notes handout, and it's really just review stuff, but let's look at this real quick. If you had this graph, how would you find your slope? Well, you would figure out your rise and your run. So I went up 1, 2, 3, 4. I went up 5. I went over 1, 2, 3, 4, 5. And so it would be 5 over 5. Always reduce. This is 1. You also always go back and look. Is my line going up or down to the right? It's going down. That means my slope is negative. So my slope is negative 1. Y-intercept is where it crosses the y-axis, so it's going to be right here at 3. X-intercept, we haven't really talked about it, but it's where it crosses the x-axis, and it's right over here. It's also at 3. If you have 2x minus 3y equal 12, you're going to have to get y by itself first. Subtract your 2x. Then everything gets divided by negative 3, so y is equal to negative 4 plus 2/3 x. Your slope is 2/3. Your y-intercept is negative 4. We have not talked about x-intercept, so don't worry about that yet. If they give you a table like this, your slope, you would say like 0 minus 5 over 4 minus 2. And 0 minus 5 is negative 5, and 4 minus 2 is 2. So your slope is negative 5/2. Your y-intercept is where it crosses the y-axis, and so x is 0. X is 0 when y is 10. The x-intercept would be where y is 0, so it would actually be 4. Not really worried about that. I'm really stressing on slope and y-intercept right now. All right, this has you ready for your assignment. If you have any questions, please call me over.